Hydrogen bonds. Hydrogen bonds are like covalent bonds. So for example, in water, the two hydrogen are coming together with oxygen H2 and one O. And now when they're sharing in this covalent bond, their electron, the hydrogen has one and the other hydrogen has one with the oxygen. Then the oxygen is pulling a little stronger at these two electrons. And it is now a polar bond, a polar covalent bond, because one is pulling stronger at the electrons as the other ones. That makes it a polar covalent bond. And such a polar covalent bond can be a hydrogen bond, and in that case it is with water. Now the hydrogen has now a little bit positive charge because the electrons, so every one of the hydrogens, has its electron a little bit more pulled away to the oxygen atom, so it has a little bit more positivity. The oxygen is a little bit more negative because it has pulled the electron towards it. And now such a hydrogen bond, these hydrogen are now more attractive to other electronegative molecules. For example, another oxygen atom which is bound to two other hydrogen bonds. So these two slightly positive hydrogen atoms want now to attract another little negative atom. For example, another oxygen atom. Such a bond is only around 5% as strong as a proper covalent bond. And it is not enough to form a new molecule, but it can make a link, for example, between different water molecules with H2O, H2O, HDO, and so on. For example, in proteins or nucleic acid. And a single one is not so strong, but there can be hundreds of them at one bigger molecule, and that they are then collectively important, and they are helping then to give it shape and form of such a bigger molecule stability. And that is important how now such a bigger molecule works in the body. And that is according to Gerald Katorga and Sandra Grabowski's Principles of Anatomy and Physiology book on the page 33 and 34, but this is no medical advice. If you click this video away, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I am trying to learn biochemistry. Today, hydrogen bonds, and after we've done with it, we're gonna do hip training. And if you participate in the hip training, then is that at your own risk. Hydrogen bonds, the polar covalent bonds that form between hydrogen atoms and other atoms can give rise to hydrogen bonds. A third type of chemical bond. Okay, there are different types of bonds. We're talking about ionic bonds. Did we skip that? Ionic bonds. We're going to do another part in the future about ionic bonds. Ionic bonds, they can form only between the same type of bonds. If I understand correctly from the covalent bond part, there are covalent bonds. They can form also with other atoms. For example, the methane, 1 carbon and 4 hydrogen bonds. And now we're talking about something else, the hydrogen bonds. A third type, hydrogen bonds. The polar covalent bond causes the hydrogen atom to have a partial positive charge that attracts a partial negative charge of neighboring electronegative atoms, most often oxygen or nitrogen in living organisms. I don't know if they're here saying that every hydrogen bond is a polar covalent bond. Non-polar covalent bond, there it is that they're having the same pulling of a shared electron in the middle. So if they're bonding together, these bonds, these covalent bonds, they are sharing an electron in the middle. One of them is pulling stronger at them. And now it is not all the time. We had here as example hydrogen molecules, and there can't be one pulling stronger. If one hydrogen atom and another hydrogen atom are sharing their one electron which we have, so that we both have them too, they are not pulling stronger one as the other one, and are both hydrogen with the same force to pull at them. By water, by H2O, there the oxygen is pulling stronger at the two hydrogen bonds, and therefore the hydrogen has a little electronegativity plus also electropositivity. Did we say it in one place? It has electropositivity. And the oxygen has electronegativity because the oxygen is stronger and pulls the shared electron of hydrogen to it, and so it has a little bit more electron, it's a bit more negative. However, it seems to be oftentimes that hydrogen is positive when it's bound with something, because hydrogen has just one proton in the atomic nuclei and is a very massless atom element. Maybe. But let's read that sentence again. The polar covalent bond causes the hydrogen atom to to have a partial positive charge. By saying it is positive, it attracts the partial negative charge of neighboring electronegative atoms, most often oxygen or nitrogen in living organisms. Now I don't understand it. We're talking about something else. First, the thing with the polar non-polar bonds. Non-polar bonds, they are pulling with the same force, so no one has electronegativity. No one is pulling the electron stronger to it, and polar bonds, one is pulling stronger. A polar covalent bond. But they seem to say something specifically for the hydrogen bond. Let's read from the beginning again and assume that it is actually a third type and forget about the rules of the previous one. The polar covalent bonds that form between hydrogen atoms and other atoms can give rise to hydrogen bonds. Can. A third type of chemical bond. And this polar covalent bond causes the hydrogen atom to become a partial positive charge, as it is with water, H2O. The two hydrogen things, the two hydrogen things are not as strong pulling on the shared electron as the oxygens. They have electropositivity because that electron is pulled away from them. Okay, hydrogen bonds. The polar covalent bond causes the hydrogen atom to have a partial positive charge, as in water, and that attracts the partial negative charge of neighboring electronegative atoms, most often oxygen or nitrogen in living organism. Does it have that partial positive charge before it has made a bond? Why should it now attract oxygen? But I have another idea now. But the trick is now we're having the trick. It does not, but as soon as it have bounded with something else, our final oxygen with our two hydrogen is water, H2O, now it is attracting the other things. After it has bonded with other things, it is bound to attract other things. To attract other things. And that is amazing. I don't know if it's true, but the thing is, so there is an element, so my hypothesis is based on what we had just. There's an element, it does not attract or whatever, but it is just there. And after it had bounded up with another element, which has taken away a little bit one electron, pulled stronger to it than it can hold it. Now it has electropositivity, and now it is attracted to other forms of elements. That means after it has come together with the second friend, the third wheel is now more attracting to the first friend because we are whatever. You get the idea. Basically, there's an element that after it had coupled up with another one, it is attractive to other elements. Let's read it again under the premises if that is what is taught here. The polar covalent bonds that form between hydrogen atoms and other atoms can give rise to hydrogen bonds, a third term of chemical bond. The polar covalent bond causes the hydrogen atom to have a partial positive charge, that attracts a partial negative charge of neighboring electronegative atoms, most often oxygen or nitrogen. Is that the reason for the cohesion of water? That with water has surface pressure. It attracts a partial negative charge of neighboring electronegative atoms, most often oxygen or nitrogen in living organisms. It gets through the bonded, the hydrogen through being connected to the oxygen in water, it gets it a partial positive charge, and now it wants to attract other things which have negative, which can be oxygen or nitrogen. The oxygen, for example, after bonding up with the hydrogen, has more negativity because it has pulled the electrons to it. The hydrogen gets partial positive, the electron is pulled away. The oxygen gets partial negative because it pulls the negative from the electron to it. Hydrogen bonds are weak, only about 5% as strong as covalent bonds. Okay? Consequently, they cannot bind atoms into molecules. So they are not as strong, they cannot bind other atoms to molecules. However, they do establish links between molecules. For example, between water molecules or between various parts of large molecules such as a protein or nucleic acid. Okay, they are not strong enough now to dock onto something else. So the hydrogen was not attracted to the nitrogen, whatever, for some reason. Now after it had bound together with the oxygen, it has electropositivity. It wants to bond up with other things. It has just a 5% of pulling force as a covalent bond because it's not so strong for whatever reason. So it is not enough to bound really up with another thing and form a molecule. But it can create a little bridge, maybe not a firm one out of stone, but a little wooden bridge. And that is enough for things in the human body to bridge over it and work. However, they do establish links between molecules, for example, between water molecules or between various parts of a large molecule, such as a protein or nucleic acid. Both discussed later in this chapter. Even though single hydrogen bonds are weak, very large molecules may contain hundreds of these bonds. Acting collectively, hydrogen bonds provide considerable strength and stability and help determine the three-dimensional shape of large molecules. Three-dimensional shape. So molecules are not just going, as the structure says it, to the side, as if it's written down in these letters or with these lines between them, but they're also going in all directions. Do we say it here? It would make a lot of sense. But imagine it not. Is the DNA 2 or 3-dimensional? Why is the DNA not 3-dimensional? Acting collectively, hydrogen bonds provide considerable strength and stability and help determine the 3-dimensional shape of large molecules. As you will see later in this chapter, a large molecule's shape determines how it works in the body. Okay, together they have quite a force and they can be part of how the whole thing looks like, whatever. We have major things. What is it? It is not as strong as the covalent bonds. It is made with hydrogen things. The hydrogen couples up with something else. Oxygen in water, H2O, 2 hydrogen with 1 O, 1 oxygen. The hydrogen loses a bit of the shared electron with the oxygen. It goes a bit stronger to the oxygen puts stronger at it. The oxygen gets more negativity. The hydrogen gets less negativity because it loses a bit of electron. It has partial positivity, and now it is more prone to team up with other types of molecules. Not as strong as a covalent bond, but if there are 2 already by water or hundreds by very large molecules, then it has an effect, then it can link for in water and whatever, and it can help to bring that molecule in a 3-dimensional space or whatever. That was for biochemistry. If you were here for biochemistry, you can go directly to this part of biochemistry. If you stay here and participate in the Hiptraining, then it's already always good. We are having the feet standing together, and we're doing the rooting tree exercise. If you participate in this, then it's always good. One toe to the outside, the other one. Heels and the heels. Toes, toes, heels, and heels. As far as you can go. And then again in. This time stay down, go on to the knees. And up. Hip width apart with the knees, bend down. Flex the leg muscles, press them together, and also straighten one leg. Press together and flex one time. And bend it again. And straighten it up. And bend again. And come up. And now a bit wider apart. Again down. Flex, press together, straighten again. Then again. Our one. And bend again. And up. I don't know what exercise. Leg to the side. No. Leg up. To the side. Breathe in. And again out and back. On to the side. Breathe again in. And then the middle leg down. One leg to the side and lift it up. When it's up, flex the foot. Other one. And one hand on tummy, one on lower back. Lift the legs straight up, try to bring it higher. And pull it up. Upper leg. And bring it up. No. Stand good on one leg. This exercise can go onto the knee. Turn over to the leg. Sink down. Slowly control over to the other side turning. Right. Our leg, stand good. Turn over to the leg. Come down. Turn slowly over. Next exercise, don't do it if you're pregnant. Heel onto the ground, lift the heel off the ground, and place it again onto the ground. Other heel. And now, the torso pointing to the outside, hold that in space between the heels, breathe in, lift the arms up. And sink down. Then go with the hands onto the floor, back up, roll slowly up the road back. Hit the top of backwards, shoulder roll. One more round, arms up. And sink down. Hands onto the ground, back up, roll slowly up, round back. Backward shoulder roll at the top. And now the airplane, or the seesaw airplane. One leg up, and bring it up, arms to the side. And because it's a seesaw airplane, up again and again. And one more. And now the hiding airplane, pull the leg in and out again. And upper leg, firstly, seesaw airplane, and the airplane, and back. And another time. Another hiding airplane, pull the leg in and again out. And back. Legs to the side, breathing it out. And breathing it out. Again. Out. Breathing, close the legs. And breathing out. That was my hip training. I thank you very much and until next time.